welcome back to the class activity discussion. So altogether we have two different questions from chapter 2. So I'm going to discuss starting with the question number 1. So in question number 1, we are going to discuss about Hess law. So given to you altogether, you have 3 different equations with different delta H, and you were given one target equation. So in your target equation, so you need to fulfill this target equation by using the 3 equations given to you. Right. From the question, this is your target equation. So what you are going to do is that you're going to use all these 3 equations with the delta H to get the target equation. So by looking at this equation, the first thing that you need to do is you need to look at which of these reactant or product that is related with your target equation. So if we can see here in the first equation, the thing that you need in your target equation that is related to your target equation is actually B2H6, and it is situated at the reactant, and it needs only one mole of B2H6. So I guess this one is okay already. So moving on to the second one, we have H3BO3, which is not related, and then we have HCl, which is related actually here, HCl, and then Cl3, BCl3, we do need BCl3 over there, and then we have H2O, so we don't need the H2O. Okay, so what we can do is that here you need the HCl and also BCl3. So since BCl3 is actually at the product, and it is indeed at the product, although the HCl should be at the product, but here is in the reactant, but it's okay. We are not going to do anything with the rearrangement yet, but both of this needs to times 2, because BCl3 times 2 you got 2 BCl3, and then if 3 times 2 you get 6 HCl. So we're just going to do times 2. So you need to times 2 for all of the things around here. Alright. And then moving on to the last one. Okay, so you have H2 not related, Cl2 is indeed related, and HCl, so we do need the HCl as well. So how much that we need to times, because we have half of Cl2 and we need to have 6 of them, so we need to times 12. So you just need to copy again all this equation with you need to times the number that you have chosen, and then only we look again whether it match the target equation or not. Okay, so what you need to do is that you need to rewrite again. So from here I've already transferred to down here. So what we need to do is that we need to slash out all the things that is not related to the target equation. So we are going to start with the H2O. So H2O is not related with the target equation, so you have 6 H2O at the reactant and you have 6 H2O at the product, so you can slash these 2 out. Right, settle with that, and then we do not need the H3BO3, so we have 2 H3BO3 at the reactant and we have 2 H3BO3 at the product, so we need to slash this out as well. Right, moving on to H2, you don't need H2, right? So you have 6 H2 here and 6 H2 here, so this can go away as well. So we do need HCl, but our HCl should be at the product instead of reactant, but we do have 6 here at the reactant, but we have 12 over here at the product, so we can slash this one. So 12 minus 6 equivalent to 6. Right. What else that we don't want? I think that's about it. We do need Cl2 and we do have the BCl3, and we have HCl. So when you already like slash all these things that you don't want, you will get the target equation. You have B2H6, this one B2H6, and then you need to have 6Cl2, so you have 6Cl2, and then you have 2BCl3, the same, and 6HCl. So what are you going to do on this part, the delta H? So you just need to do the summation of the delta H. So you add negative 493.4 kilojoule plus 225 kilojoule plus negative 1107.6 kilojoule. So altogether, you should get the delta H. For this, delta H should be equivalent to negative 1376 kilojoule. Right, so this is your final answer. So altogether here, you should be able to understand the Hess law, and then from the Hess law, you need to know that from all the equation given to you, you need to use everything to get your target equation. Right. Question number 2. 14 gram of metal at 297 Kelvin has 250 joule of heat added to it. The metal specific heat is 0.105 joule over gram degree Celsius. What is its final temperature? Okay, this is a very straightforward question. You just need to use the formula Q equivalent to ms delta T. Right? So the value of Q is given to you in the question. 250 joule, and then the mass is given to you in the question as well, 14 gram, and then the S, the specific heat given to you is equivalent to 0.105, and the temperature. So the final temperature is unknown, is the thing that you want to calculate, and the initial temperature is 24 degrees Celsius. So from here, you get 250 is equivalent to 1.47 final minus 24. So you should get your final temperature is equivalent to 285.28 divided by 1.47. Therefore, your final temperature should be equivalent to 194.0680 degrees Celsius. Alright, so from here, you need to know what is the temperature here in Kelvin. So you want to convert in Kelvin, means that from degree Celsius to Kelvin is plus 273. So plus 273, you should get 467.068 Kelvin. So this is the final answer. Okay, this is the end of our discussion from class activity. I wish you all the best for your quiz too. So study smart, and I'll see you again next week. Goodbye.